Um, Today we will continue our discussion on Ethernet, right? Last time what we discussed was regarding to Ethernet cabling, right? In that we concluded that we are having four different type of uh, variations in the standard Ethernet, and what is the meaning of each that we have already discussed. Right now today we are going to learn that once we decide the cable, okay, now I need to send 1010 on that cable. I will choose for coaxial cable, or I will choose for fiber optic or twisted pair, right? So I have a cable. In that I have to send 1010. Okay, so how will should I send 1010 or whatever 00, whatever the bit stream? How can I send them? Right. For that, what is your idea? What comes in your mind? How will you send it? Suppose I want to send 10. Are you going to throw the numbers? How are you going to deal with that? Are you going to throw the numbers? How will you send 1010 in the cable? Already we have discussed. Be quick here so that we can cover more things. Tell me, how will you send numbers on the wire? Because you have to transmit binary values so that it can be detected on the other side. Yes, convert it to analog. No, we will not convert into analog. It is digital signal only. No, use signals. True, that is true. Analog and digital is a different thing. What you are saying is convert into some signal, right? It is not analog. Analog is what? This is digital signal anyway, right? Priyank, what is analog? Analog is a different thing, where for every point of time you have some value, where here if you will see, for this point of time it is having value 1 and it is constant for this much of time, right? Then it is 0, then it is constant for this much of time. So this is digital signal. Only two values is possible. Like suppose you are having some signal like this and you are having some signal like this, you will understand it, this is 1 and this is 0. Why? Because it is not possible to have these values and it is not possible to have these values amplitude wise. If I say this is the amplitude range, then above 5 or below, I mean less than, suppose this is -5 level, right? So this can be -2. If this level is -2, you will come to know, okay, it is 0 anyway. If it is +5, this is 7, you will come to know it is anyway +1. So here only two values are possible, +1 and -1, and that's why it is a digital signal. Where analog, if it is analog signal, then 5 values possible, 7 values possible, 2 values possible, -2 values possible. So you will not come to know, if you are detecting 7 here, you will not come to know whether it is 7 or 5. And that's why it is analog signal. So it is a separate issue. But what you want to say here is that 1010 bit stream we are having, then we will convert them into voltages and we are going to send those voltage signals. Yes, Abhi, you are correct here, right? So now, okay, now in your system, suppose you are designing a system where you're designing your network. How you have to send the signals. You have to decide the voltage levels. Tell me what voltage level are you going to decide? What comes in your mind as a designer? Which voltage level you will use for 1? Which voltage level you will use for 0? What is your idea? +5 and -5. So here you are saying that, okay, that is your choice. But is it possible that Abhi will say, I will use +2 and -2? Is it possible that someone else will say that, Preet will say, it is say +10 and -10? Is it possible? Like all of you will work on the different one. Is it possible? Right? So in that, what will happen in that, so this is required to be standardized. Okay, now someone will say, no, I'm not going to use +5 and -5. This is, I'm going to use +5 and 0. +5 and 0 for 0 for 0 and plus voltages for 1. It is possible. Someone will say, no, I'm going to use the reverse way. No voltage for 0, +5 volt for no voltage for 1, and +5 volt for 0. Possible, right? Someone will say, no, I'm not going to use that. I will use a different scheme. I will use a different scheme. In that, I will use two levels. Say this type of level for this type of pulse for +1, this type of pulse for minus 1. Is it possible? So it is not like square wave, it is a different one, right? There are two square wave levels, two levels for plus 1, two levels for 0. So what is my point here? That you want to send ones and zeros on the cable, but various methods are possible, and this requires to be standardized. And see, what you are saying, plus 5 and minus 5, it is known as polar kind of coding. It is known as polar type of line coding. This is known as line coding. This process of assigning voltage levels to binary values is known as line coding, right? So each line code has its own advantage and disadvantage, right? And right now it is mostly in terms of repeaters. See, what will happen, suppose I'm using polar, that is plus 5 for 1, minus 5 for 0, and it will travel in the cable, so it is going to get degraded. It may become like this. So repeater will detect this and it has to regenerate it. So it will regenerate like this. So it has to detect and it has to regenerate, right? So you have to provide clock to repeater so that it can come to know when to detect, and what is the frequency, everything you must provide to repeater. So in those terms, every line code has its advantage and disadvantage. Right now we are not going in those details that what are the advantages of each line code, but what is the point here, that different line codes are possible. That means you can use polar, you can use on off. What is on off? That plus 5 for 1 and no voltage for 0, that is on off, on or off, right? In the reverse way, like someone will say, like the reverse, like no voltage for 1 and plus 5 volt for, and the plus 5 volt for 0 and no voltage for 1. So again, so what we are concluding from this discussion is that there are multiple types of line codings are possible, one thing. Second, whichever line code you are using, that must be standardized. Like, are you using plus 5 or minus 5, plus 10 or minus 10? That must be standardized, second thing. And those standards must be clear between to whom? To transmitter and receiver only. We don't require, I mean, if transmitter and receivers are clear with that, no need to, I mean, it is not, every transmitter receiver can have their own understanding, right? So that so are you using polar or not, are you using which voltages are you using? So every time what happens, that you have to, whenever you decide to communicate, at that time you have to make agreement here, that are you going to use plus 5 or minus 5, are you going to use this or that, all those agreements you need to make. So instead of making agreement every time, we can develop a standard here. We are having a scope here, right, to develop a standard, that if I will say I am using this standard, that means I am using this voltage levels, I am using this type of line coding, and etc. Different things, that this will be my also that those things are standardized, right? So receiver will come to know, okay, we are using this standard, everything is clear, so no need to make agreements, service level agreements here. So that these things are included in IEEE 802.3. What is that? Ethernet. IEEE 802.3. What is in that? What they have decided? Let us use Manchester coding. Line code is what? Manchester line code. Let's use Manchester line code. What that Manchester line code says? For 1, send 1 and for 1, send plus voltage level and then minus voltage level. For 0, send minus voltage level and then plus voltage level. For 0, send minus voltage level and plus voltage level. So what we are deciding, for 0, minus first and positive later. This is for 0, right? And for 1, that will be positive pulse first and negative pulse later. So that will be for 1. So if I want to write 0, that means negative first, positive later. Negative first, positive later. Here if you will see, there is a center line. If you can see the center line here. Okay, so negative first, positive later. Negative first, positive later. 1 is positive first, negative later. So whatever bit duration I have, instead of sending plus voltage for 1 and negative voltage for 0, I am sending 2 pulses per bit. Okay, so so we'll say why you are doing so, but it has its own advantage in terms of clock, right? It is easy to extract clock from this type of signal, but how, why, when, what, it is not right now our concern. But what is the advantage? The repeater will be able to detect clock, so that it will come to know when to detect. So you don't have to send separate clock for this type of coding. So otherwise what happens, that you have to send timing information as well, when to detect, so that you can regenerate. Okay, so that's why this Manchester encoding is helpful, right? So now if you will see, okay, so are you clear with this Manchester line code, that how it is getting executed? So how will you detect? How will you detect it? How will you detect whether it is 1 or 0? So you will see, you will start from this bit duration. You will see first positive pulse is encountered, then negative pulse is encountered, that means it is 1. And then you will start again this on this bit duration. First negative pulse is encountered, then positive pulse is encountered, that means it is 0. So this is all about Manchester coding, right? So now, so what we have standardized in 802.3, that we will use Manchester coding. Another thing that what we have standardized, that voltage level. What is that voltage level? It is plus or minus 0.85 volts. So this is plus 0.85 volt, this is minus 0.85 volt. So this is what is standardized. This is sufficient. That is what they think. Okay. So this is all about Manchester coding and detecting of that. Now one thing comes is baud rate. Do you understand baud rate? What is baud rate? What is baud rate? Anyone is aware about a baud rate? Speed of sending data. So can I say bit rate is speed of sending data? Preet? Number of bits transfer in a particular, so it is a bit rate, na? Preet and Abhi, it is bit rate. How it is different from baud rate? Adik, you are true. You are correct here. Preet and Abhi, both of you are correct here. So actually, eventually, it is giving us the speed of transmission only, speed of sending data only. But actually, we are measuring the speed of transmission using bit rate. Na? So we have concept of bit rate. Then how it is different from baud rate? So let me tell you. Are you? I think you are not clear. All of you are not clear with this. So let me tell you the concept first. Baud rate is what? That number of signals per second, number of time the signal changes its state. Okay, so now suppose I am I am using polar. What is polar? Polar is that for 1 I will send plus 5, and for 0 I am going to send minus 5. So what is bit rate? Now let us, this is polar line code I am using, right? Now tell me what is bit rate. Bit rate is, say, suppose my bit rate is say 10 beats per second. For simplicity, I'm taking 10 beats per second. So what is the meaning of that? In 1 second, I'm going to send 10 bits. 10 bits I'm going to send. That means 10 ones and zeros. I mean totally 1, 0, 1, 1. In that way, I'm going to send 10 numbers. That is the meaning? Right? So fine. So that is my bit rate. So how many bits in 1 second we are sending? Okay. So now if I want to send 10 bits, how many pulses I will require to send if I'm using this line coding? How many pulses will I require to send? So for transmitting one, for transmitting one, just a second. So think about that. How many pulses you will transmit in 1 second? I'm coming back. Okay, so what is your conclusion here? What is your conclusion? What is your conclusion here? Am I audible to you? Okay, so how many pulses we will require to send if I want to send 10 bits per second? For one bit, I'm yes, 10 pulses I require to send. Okay, for each pulse, how many times? So, if I'm sending one pulse per bit, that means I'm having one label per bit. I'm having only +5 label for one and -5 label for zero. So how many labels I'm sending actually? How many? If for one I'm just using one label that is +5 volt, and for zero I'm using -5 volt. So I'm using one label per bit. Yes or no? So how many labels I'm sending? How many times? How many signal labels I'm sending? So it will be 10, right? So that is what is here my. So how many signals? How many pulses I'm sending is my baud rate. So you will say, okay, you are sending 10 bits and you are sending 10 pulses. That means you are um, that it is the same thing. No? So bit rate and baud rate is same. Yes, I agree. Here bit rate and baud rate is same. What is bit rate? Number of bits per second. What is baud rate? Number of pulses per second. That means number of labels per second, right? So you can say yes, here bit rate and baud rate is same. But now think. Now think. Suppose I am using 10 and I'm using 4 different pulse level. I am using 00. I am using 01, I am using 10, and I am using 11. So for that, for 00, I will use say +5 level. For 01, I will use say +10 level. For 10, I will use -5 level, and for 11, I am using -10 level. Is it possible that I am using this type of pulse? That means if suppose I am detecting +5, that I should understand it is 00 level. Suppose I am detecting 1, if I am detecting 10, so I will understand it is my 10 level. That means it is 10. Then if I am detecting again +5, that means I will understand it is 00. And if I am detecting -10, that means I will understand it is 11. So now if I want to send whatever my bit string is, say 10, if I want to send this bit string, okay, so we are using like this: +5, +10, -5, -10, right? So now suppose here this is 10 I want to send, I'm going to use 10, that means -5 level, 11, that is -10 level. Are you getting the point? So can you tell me for 10 bits how many pulses I'm sending? For 10 bits it will be 5. So this, what will be my baud rate? Baud rate will be 5 bauds per second. And what will be my bit rate? What will be my bit rate? 10 bits per second. So how baud rate and bit rate are related? How baud rate and bit rate are related here? Bit rate is twice the baud rate. Can I say so? Huh. Baud rate is half of the bit rate. True. Okay. Now can you tell me what is bit rate in Ethernet? Standard Ethernet. What is the bit rate of standard Ethernet? Have you studied that? What is bit rate of standard Ethernet? What this 10 indicates? What this 10 indicates? So it is a bit rate. 10 Mbps is a bit rate, right? So okay. So now what about baud rate? What is baud rate in Ethernet? It uses Manchester. What is baud rate? Yes, it is 20 because 2 pulses per bit we are sending, right? We are sending 2 levels per bit. So for sending 10 bits, I will require to send 20 pulses. and hence 20, if I'm sending 10 MB bits, I mean 10 million bits per second, then I have to send 20 million pulses per second. So how bitrate and baud rate are related in Ethernet? How bitrate and baud rate are related? Baud rate is double from the bit rate. Yes, you can say baud rate is double compared to the bit rate. True. So this is all about Manchester encoding and Ethernet relation, right? But sometimes if you have heard about, I'm sure that madam has covered that 2.4 and 2.5 as well. That is time that bus and token ring topologies. In that, if you heard that differential Manchester encoding is used. So this is another kind of line coding. So in that, what happens how will you send one? So for one, you will use the same pulse as the previous, and for 0, you are going to send what you can say, you are going to use complement of the previous, right? So, or rather, sorry, I'm wrong here. For 0, you are going to use same pulse as the previous, and for 1, you are going to use complement of the previous pulse. Okay, so let us start with that, because it is 1. Let us start with any pulse. So for 1, let us use the same one initial, because it is the first one you have to start. Ideally, what you should do, if 1, then complement of the previous, but it is the first bit, so you don't have the previous bit, so you have to start. So for starting purpose, you are taking this logic that you are using plus, you are using this one, like what we can say, this positive pulse and negative pulse. Okay, for 0, what it says, 0 is same as the previous pulse. So for 0, same as the previous, positive and then negative. For 0, same as the previous. What is previous? Positive and then negative. 0, same as the previous, positive and negative. For 0, same as previous, positive and negative. 1. 1 indicates complement of the previous. What is complement? If this is positive, it should be negative. If it is negative, this should be positive. For 0, same as the previous. That means whatever the previous was this one. So negative and then positive. Then 1, complement of the previous. Complement was, what will be the complement? First negative, then it is positive. Then positive, then it will be negative. So this is a complement of the previous. Yes or no? And then, are you clear with how differential Manchester works? Initially, you will start, then you will go with 0, then same as the previous. 1 is the complement as the previous. Okay. So now how to detect? So if you will detect this pulse, right? Here earlier it was easy, positive and then negative, then 1, negative and positive, then 0. But it is not true here. Like here for 1, it is positive and negative, and here for 1, it is negative and positive. So you cannot have that logic here, right? So how to detect? So for detection purpose, there is a logic here. What it says that at the time of new bit, if you find a transition, then it is 0. At the time of new bit, if you find transition from low to high, so it is 0. But at the time of bit, if you don't find any transition, then it is 1. So at the here, so now let me tell you. Tell me now here at the beginning of the bit duration, you are finding the transition. That means it is 0. At the time of bit change, you are not finding the transition. That means it is 1. At the beginning of the time slot, you are not finding the transition. That means it is 1. Are you clear with the detection scheme? Are you clear with the detection scheme? That's good. That's good. So this is all about differential Manchester encoding. It is particularly used for 802.4 and 5. Okay. Bit rate baud rate relationship will be same as the Manchester encoding, because 2 pulses per bit it is used. So this is all about differential Manchester encoding. Now let us learn about a new thing, that is frame. Let us learn about the frame now. Okay. So what is frame here? So see, okay, you will say I am going. So what we have studied so far, that I will have multiple computers. How they will be connected with each other? So if it is using Ethernet protocol, then they have a bus topology or they have a star topology, that we have concluded. So let us assume that we are on the bus topology. So this we understood that we are either using we are using either this standard or we are using this standard. Or someone will say, no, I'm going to use the star topology, then you are using this standard. So now I know that which type of cable I'm going to use and everything, right? So those basic ideas I know. Then I will say, okay, I'm connected with my machine. Then how will I send my bits? 101010. So I know that, okay, I'm going to use Manchester. This is my standard. And this is how the bits will travel from this to this. So this is also known to me. But now the question is, what is the meaning of this 1010, whatever I'm sending the bit stream? What will be the meaning of it? How I will form my frame which I'm going to send. So that is the next thing. That is, so what will be the format of that frame, so that next machine will understand, okay, this is meaning of this bit. Okay, so that frame format is coming next. Okay, so now initially that Ethernet, see, any standard doesn't come into picture in just without any what you can say background. It is just from the next morning the standard will be there. It doesn't happen. It is always in the practice, and then it gets modified, and then it becomes worldwide use. Otherwise, next morning you are deciding, that will not work in that way. It takes time to evolve, right? So initially few companies were there. They were this is known as a group of companies. Few companies were there, and initially they were Xerox. This X is for Xerox, and this is Digital Corporation was there. So in that, this is actually group of multiple companies, and if you want to check, one of them is Xerox. X is for the Xerox here, and this ED is for the digital what you can say digital group of that companies, we can say. But here, if you want to know that which were those companies, 2 or 3 companies were there. They were together using a certain frame format, and that was quite popular. That was quite effective, and it was not having, I mean, it was working. It was good in terms of performance. So what was that format? So that frame format was this one. This is in terms of bytes. What is that? First 8 bytes are preamble. The next 6 bytes are destination address. Next 6 are source address. Next 2 are type. Next will be the data. Next will be the padding if required, right? And then checksum of 4 bytes. Now let us learn. So this is, if you remember. Okay, now let us. So we have to understand what is meaning of this, and after that. From this frame format evolved, and this is of IEEE 802.3 format. If you will see, majority things are same, right? Only here some changes there, and here some changes there. Okay, so what is that we will understand. So let us learn first what was original frame format, and then let us understand what are the changes. Okay, so now. Initially, if you will see, it was preamble. What is preamble? Preamble is just one. It is just 101010 time. That is how many bits it will be. It is a combination 101010. It is continuously 101010. It is like a pattern only 101010. Can you tell me how many bits it will be if how many how many bits I'm going to send if I'm sending 8 bytes? How many bits will be preamble? How many bits will be preamble? 64 bits will be preamble. Very simple. It is 8 bytes. That means 64 bits. That means 64 times I'm going to send one and 64 bits I'm going to send. And what will be the pattern? Pattern will be 101010. Right? 32 times 1, 32 times 0. Like that. Right? Okay. So how much time will it take preamble? How much time will it take this preamble? 64 bits. How much time will this preamble take in transmission? What is transmission speed currently? What is my bit stream? What is my bit rate? What is my bit rate? 10 Mbps. So in 10 MB bits, 10 million bits I'm sending in 1 second. So 64 bits I will send in how much time? How much time will it take to reach? I mean, preamble will take how much time of this frame? How much time will preamble take on the channel? Are you getting my question? Yes, it will be 6.4 microsecond. True, it will be 6.4 microseconds. True. So this 6.4 microsecond is not having any meaning. 6.4 microsecond is not having any information because everyone knows first 6.4 microsecond will be 101010. So you will say, okay, but why are we sending? Why we are wasting our 6.4 microsecond? Actually, we are giving time our receiver to tune to our tune to our frequencies, right? Because it has to detect, because it is possible that currently I am sending data at 10 mbps speed, right? But my receiver has capacity, more capacity, and it is working on some other speed, or it is doing some other task, so it has to stop it task, it has to come back, it has to listen my frame. So we are giving some time, buffer time to receiver, so that it will either it requires to tune, then it will get tuned, it will, if it is doing some other task and want to come to the channel and listen something, then for that purpose we are giving this 6.4 microsecond for a receiver to tuning, so that it will not miss anything in further. Okay. So so fine, but what is the change here in ethernet frame? So it is having preamble, but the last byte is a start of frame. What it indicates, preamble is 101010 only, but last byte is start of frame. How it is designed, it is also 101010 and 11. Instead of 10 last, we are having 11 here. So what is the meaning? It indicates that if you are receiving after 1010, if you are receiving 11, it is kind of start bit. Now your frame is going to start. This is where your frame actually starts. Okay, so this Ethernet changed. What it changed? It along with preamble. Preamble is what? All 7 bits, 7 bytes, 101010. What is start of frame? Start of frame is 101010 and 11. After that, what will happen? After that, this is the end of 8th byte, right? And it indicates that after that my frame is going to start. So it is acting like a start bit kind of thing that you have studied, right? So it is similar through that. So start of frame is SOF. So this time is just extra time, and it is not considered as part of your frame. This is not part of your frame. This is extra time generally given to receiver. This is not part of your frame. Is it clear to you, everyone? This is frame starts from destination address. Okay, fine. So now what we are doing here is, okay, so now let us learn about destination address. So which this is now very easy. Like this will give us the destination address, 6 byte of destination address, 6 byte of source address. Can you tell me which address is this? IP of MAC? Which address will be? Yes, it is a MAC address. True. So it is a MAC address because we are working on the MAC layer. We are working on the data link layer. So it indicates the physical address of the device. Okay. Now, how many bytes? How many bit long the MAC address is? How many bit long it is? 48 bit. That means 6 byte. 48 bit. That means 6 byte. Okay. Now, your which are the types of MAC addresses? So your MAC address can be unicast, your MAC address can be multicast, or your MAC address can be broadcast. What is the meaning of unicast MAC address? Unicast is what? That if you are saying my MAC address is unicast, that means it is indicating just one machine. If I say my MAC address is multicast, that means it is indicating group of machines, right? And if I say it is a broadcast, that means it is indicating all the machines are involved here. Okay, now suppose I am putting my unicast address as a destination address. That means that frame is meant for that unicast address, that means just one machine, right? If I say that if this address is multicast, that means this frame is meant for group of machines. And if I say that destination address is broadcast, that means this frame is meant for every machine on the network. Okay, so now you will say, okay, how will we identify whether my address is unicast, multicast, or broadcast? So for broadcast, it is very easy. It is all ones. All 48 bits are 1. That is FF, 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 FF. So all 48 bits are 1. That is what broadcast MAC address. Right? It is actually one-to-many communication. Okay. Now, if you will see, now if you will go for unicast address. What is unicast address? So in that, see, there are, this is your MAC address, right? You know that it is having 6 bytes, 6 bytes, that means 48 bits. So this is my first byte, second, third, fourth, fifth, sixth, right? So last bit of my first byte, if it is 0, then it is unicast address, and last bit of my first byte is 1, then it is a multicast address. Okay, so now can you tell me this is unicast or multicast? How will you come to know? So we have to take first byte and then last bit. So what will be last bit of this address? How will you write? So it is 1010, that is A, and 2 is what? This is hexadecimal number, right? So what will be 2? So it will be 0010. So can I say, yes, it is unicast because last bit of my first byte is 0. Same way here, it is A3, that means A and 3. So this bit will be 1 and hence it is multicast. So this is how you can identify whether your address is unicast or multicast, right? Okay, can source address be multicast? Can source address be multicast? No. Multicast or broadcast can be the destination address only. I mean, group of sender will be one. It can send to multiple, right? Or it can send to one, or it can send to all. But multiple will send to one is not the situation, right? That will be one-to-one communication many times if it is the case. But group of senders cannot be in the multicast. Senders cannot be multicast, right? Sender address cannot be multicast address. That is what the point is. So this is all about type of addressing. Now, one more important thing. How this, so first of all, so sometimes what is required, like as soon as the receiver receives a frame, it is required that it should understand whether the message is unicast, broadcast, or multicast. If it understands quickly, that will be better for the operation, right? So what, as soon as the frame is received, if receiver can detect that whether the destination address is unicast, multicast, or broadcast, it will be better for it, right? So that's why what they have decided, it will be easier. Again, if you are not having, it is not impossible to handle, but it will be easier if you are having. So what they have decided, that let us send this bit first. That means how you will send this address on the channel, how this destination address is kept on the wire. On the wire, how will you send? You are going to send this bit first. Then you will send this bit, and you will move here from left to right on the first byte, right? Then you will go for next byte. Again, left to right on the second byte. And in that way, you will move in this direction. Sorry, I'm wrong here. Left, right. Sorry. What is that? Right to left. I'm just, the logic is same, but just I have mentioned the left, right wrong here. Sorry. So what we are doing here? Okay. So first I will take my first byte. I will move from LSB to MSB here. LSB to MSB here. So right to left here. Right? Then I will take this byte. Again, LSB to MSB I will transmit. So actually I am moving on the address in this direction, but then I am taking the byte and I am moving in the particular byte in the reverse direction. Okay, so this is how we are sending. So can you tell me which one will be the first bit that I am going to encounter? Which one will be the first bit that I am going to encounter? Here. This bit I'm going to encounter. Which one is that? The LSB of my MSB. LSB of my most significant byte. Least significant bit of my most significant byte. Are you clear with that, everyone? Are you clear with the methodology? Okay, so now let us go with this example. So this is my address. How will you send it on the line? How will you send this on the line? So can you tell me what will be the bit pattern? So let us write our address in binary form. So 4 and then 7. 47, 2 and 0, then 1 and B. Are you getting that? In that way, it is written completely. How will you send from this? Can you tell me? What will be the bit pattern? What I will send first? Which bit I will send first? Tell me. No need to write entire pattern. First, I will send 1. Then what will be the next one? Next one will be also 1. Next one will also be 1. Then what it will be? Yes, it will be 0. 3 times 0. What will be next then? 1 and then 0. What up next then? Yes, again is 0 because I have to take this one and in that this first. Then 0, 0, 0, 0. What is 0, 0? 0, 0, 0, 0. Then 0 and then 1. So on. I hope you are getting the case. 0, 1, 0, 0. So this is what we will send. Are you get clear with this idea? What to send, what to do? In that way, this is transmitted on the channel. One more thing that comes with the address is what that that address is global or local. The address is globally recognized or locally recognized. Like private IP and public IP, the same concept. Public IP is what that is globally known. Same way, global MAC addresses are known in the entire world. It is unique in the entire world. While local is local MAC address will be unique in your network, but outside it is not recognized. Same as public and private IP. Same way we are having the concept in the MAC, right? So. So local MAC address is given by your administrator, and global MAC address is given by what you can say that the device provider, or it is given by your the one that produces your NIC card, right? So in that way it is given. So how will you identify it is local or it is global or local? So for that you are going to use 46th bit on the line. Can you tell me which one will be 46th bit on the line? Which bit will be 46th bit on the line? Which one will be 46th bit? I mean, okay, let us give the number. How long my address is? How long my address is? How long the address is? MAC address, how long the MAC address? 48 bits. So can I number it as from 0 to 47? 0 to 47. So 47 bits will be on the line. Okay. Can you tell me which one will be 47th bit on the line? On the line means what? I'm not asking actual address. I'm asking on the line. Which bit will be 47th bit here? In this address, which bit on the line will be 47th bit? I am giving number from 0 to 47. No. Try to what I'm asking is for this address, which 47th is no. See, okay. Can I say that suppose I'm taking this one? So this address is having actually the number will be actually I'm giving suppose my bit number I'm using 0 to 47 bit numbers to identify 48 bits. Okay. So any issue here that I'm using 0 to 47 numbers. Okay, actually whatever it is, but if I see on my channel, I will see 0 to 47 like this. This is online. This is how online it is going to look. So which one will be my 47th bit? This bit. And which 47? This is 47th bit on the line. On the line means what? On the link on the channel. So this one will be my 47th bit on my channel. But actually, which bit is it? Is actually it is this bit. Are you getting the point? 47th bit on the line or on the link is actually this bit, that LSB of my MS most significant byte. Now in that way, can you tell me which bit will be 46th bit? Which bit will be 46th bit on the line? On the line, 46th bit will be which bit of my original address? Here in this case, can you tell me which one is 46th bit? 6th bit of, not 6th bit, Just check it once again. Original data, is it 6th bit or 7th bit? Yes, last second bit of my first byte. True, that is true. So of this one, I will take this one, which will be 46th bit, right? So this one is my 46th number. Actually, what it is? Actually, it is this one. So this 46th bit on the link represents whether my address is local or global. 0. You will start. I am telling. I am giving number from 0 to 47. Okay, we are using numbers from 0 to okay. Oh yes. So you are saying 6th number. I agree. So no. I agree. That is true. True. See, I agree. That was my mistake. That was problem. But I am talking about this. Whatever the number you want to give, I agree. If you are starting from 0, then it will be 6th bit. I agree. But let us do not have that confusion. Let us have this bit. That is, let us take that Preet's idea. That is good one. Last second bit of the first byte. That is more informative, right? So are you clear with that? Which bit will be? All of you are clear with this? So this bit, if it is 1 or 0, then it is global or global or local. See, we have to see that in Wireshark we are going to verify that whether 1 indicates local or global. I have missed that part, that 1 indicates local or global. I am going to tell you that one part is out of my mind. But if this value is 1, then either it is local or global, and if it is 0, then the otherwise. I will tell you 1 indicates what, 0 indicates what, right? I have to verify that once again. But anyway, we will see that in Wireshark also we are going to see, so it will not be the problem. But in short, this bit indicates whether it is 1 or 0. I mean, whether it is local or global. Okay, I have missed that portion. I've just I've forgotten that. I am going to tell you in the next one, like next lecture. Okay, fine. So fine. So now fine. Now what we are doing here is next one is the type field. What is type field? That it is like a protocol field of IP. What was protocol field of IP? What was protocol field of IP? No, protocol field of IP was to which upper layer protocol this should be delivered to. Same way, type indicates to which upper layer, network layer protocol it should be delivered to. So type is which type of protocol we should deliver it to. Okay, now next is checksum. Do you see? If you will see, this is my data part. This is actually data part, or rather I should not say, this is my data part. This is my data part. So this is my trailer part. If you remember, in data link layer, we are adding header and trailer. So this is my header part, and this is my trailer part. Okay. So header and trailer is indicated with data. Data is 1500. So can I say what it includes? It is like in my frame of my data link layer, I can include 1500 bytes. And this is what is MTU. If you remember, we have studied that in ping, that Ethernet has 1500 bytes of MTU. Have you studied that? Have you seen that in ping? Or in IF config or something? Have you seen that MTU was 1500? Do you remember it? This is MTU. MTU is what? That this much data you can fit into a frame. Right? That means IP, header, and the data part together should be of size 1500 bytes. Okay. Now, what is padding then? Checksum, you understand, right? Checksum is what? It is going to have a checksum of not preamble from this frame. Of course, not preamble. Preamble is not considered in the checksum, but otherwise the data is chunked into checksum concept, you know, right? So it is actually including data and header part and this all part. So checksum is for that. So checksum you are clear with. Okay. Now to understand this length, we have to understand this padding first. What is this padding? So if you remember, I told you that Ethernet is using CSMA CD for the MAC layer. So what should be the minimum size of the what should be the minimum size of the frame? How long the frame must exist so that collision can be detected? How long the frame should be so that collision can be detected? Yes, two time delay, right? That delay includes so okay, two time propagation delay. So that means if I have one machine here and other machine here, and how much time will it take to reach here and to come back? That is two time propagation delay. So that time actually is that long it should exist. Okay, now in our case, I know that maximum length between A and B can be 2.5 kilometer. That we concluded last time, that you can use maximum 4 repeaters and each can be of 500 meter segment and hence totally 2.5 kilometers. So what they concluded, that let us take the worst case scenario where the A and B are having 2.5 kilometer distance between them and they are using 4 repeaters. So this propagation delay is going to include this traveling time and it is going to include this repeater time, right? And what they concluded, that time is what they concluded, this propagation time is one side propagation time is and okay, two time propagation delay, this entire propagation time is 50 microsecond. On an average it takes 50 microsecond to go and come back, because it will take propagation because data rate is fixed 10 mbps, so speed and everything. And of course we are using we are using this light, we are using the electromagnetic waves, so the speed is also fixed, that 2 into something is the 2 into 10 is to 8 is 2 into 10 is to 5 is the speed of electromagnetic wave, which is also fixed. So from that we could get the judgment that it will take 50 microsecond to go from this and come back. Okay, so how many bits are we will be able to send in this 50 microsecond? Can you tell me, if I'm sending bits at 10 mbps speed, how many bits will I be send? I should send in this 50 microsecond. 50 microsecond, for that much time I should keep sending the bits. So how many bits actually I should keep sending? So in 50 microsecond, how many bits will go if I'm using at the 10 mbps speed? In 1 second 10 MB bits are going. In 50 microsecond, how many bits will go? Are you getting my question? In one yes, it will be 50 or 500. Will it be 50 or 500? In 1 second 10 MB data, then in 50 microsecond how much data? So it will be 500 bits. So your minimum size of your frame must be 500 bits. But 500 bits, that means how many bytes? 500 bits, that means how many bytes? So it is going to be very awkward number. So better we are taking it 512. 512 bit should be the length of my frame. Minimum length should be my 512 bit. If I'm waiting little bit more than the minimum required time, that is not harmful, right? So what is minimum frame size is taken? 512 bit. Minimum frame size should be 512 bits. So how many bytes it is? 512 bits, that means how many bytes? 64 byte. That's why minimum frame size must be 64 byte. So suppose you are not, so if it is not, if your data is less than 64 byte, or if your frame size becomes less than 64 byte, then you need to add padding. Padding is what? That it is just you are adding extra zeros here. Okay, so what is the size of padding you may require? So suppose you are using data. Okay, so now you have to understand your total frame size should be 46 bytes. Okay, so how much data you must have? So forget about the padding. Suppose you don't want to add padding, what is the minimum size of data you should add? So you will say, okay, 6 byte of destination, 6 byte of source, that is 12. No, compulsory 1500 bytes are not required. Sometimes you don't send 1500 bytes all. It is maximum size that 1500 you can send. Okay, maximum 1500 you can send. Okay, so now can you tell me what is the minimum amount of data that you should send if you don't want to send padding? So, okay, so you need to have this frame size 64 minimum. That means already, so if you're not sending the data, even then you have to send the source destination address, source address, and the type. So 6 plus 6 plus 2, already 12 plus 2, 14, and 4, 18. 18 bytes you are anyway sending. So for in 64 bytes, 64 byte, already 18 bytes you are sending. So how much is minimum data requirement? You have to send minimum data if you don't want to send padding. Yes, it will be 46. It will be 46. True. So 46 byte of data if you have, then you will not require any padding, or 46 or more. If any data is more than 46 or greater than that many bytes, then you will not require padding. But if your data is say 45 byte, then you will require one padding. Earlier, you were not requiring any padding, zero padding. Then you might require one padding if it is 45. And if your data is zero, then you need to make this field 46 byte long, and you might require 46 byte of padding. So your padding can vary from 0 to 46. Is it clear to all of you? Padding one. And this length field indicates that how much your actual data is, because you will not come to know whether all zeros are your padding or it is data. So this indicates the length of your data. In how much is the padding part, how much is the data. So what can be the maximum value possible here in the length field? Maximum value of the length field possible is, your data can be maximum 0 to 1500. Yes, so maximum value of the length is 1500 here. Okay, so now what actually happens, now earlier this was in the practice and then this was proposed, and currently both are in use, right? So you will say, how will you come to know whether we should understand this field as a type field or the length field? Luckily, whatever was proposed in the type field is indicating a number which is meant for the upper layer protocol. I'm delivering it to IP, I will have a number for that. Those numbers were greater than 1500, and length cannot be greater than 1500. So whenever you encounter this field, and if this field value is greater than 1500, that means it is behaving as a type field. And if you are having that value less than 1500, that means it is behaving as a length field. So this is all about MAC frame. Any doubt up to this? So this is all about Ethernet frame. This we have already discussed regarding to 2 tau. Last lecture we have already discussed, so I'm not going to repeat it. That means you have to keep 2 tau long your frame. That's it, nothing else. So this is all about your Ethernet frame. In the next lecture, we will discuss regarding to binary bake-off algorithm. Any doubt in case you can approach me anytime. For now, you may leave.